Good day, everyone. I'm Catherine Rizal, and today we will explore the world of plane geometry. In this lesson, we will study the fundamental ideas of geometry, triangles, right triangles, polygons, parallelograms, circles, geometric solid, and areas and volume. So by the end of this video, you shall be able to identify and classify lines, angles, triangles, and other geometric figures, understand and apply triangle congruence and similarity postulates, solve problems involving parallel lines, angle sums, and distances. Fundamental ideas of geometry, which serve as the foundation of all shapes and figures. First, we have points, lines, and planes. So points show exact location, lines extend infinitely in two directions, and planes are flat surfaces. Together, they form the basic structure used to describe shapes and geometric relationships. Next are postulates and theorems. So postulates are statements accepted as true without proof, while theorems are proven using logical reasoning. So they guide problem solving, explain geometric patterns, and help establish reliable mathematical. So now let's discuss segments, rays, and midpoints. So segments have two endpoints and measurable length. Rays start at one point and extend infinitely, and midpoints divide segments into two equal parts, helping measure distances and locate positions accurately. So angles and angle pairs. Angles are formed by two rays meeting at a vertex. Measuring rotation, angle pairs such as complementary, supplementary, vertical, and adjacent angles describe relationship and help analyze geometric figures. So these fundamental concepts prepare us to study more complex geometric shapes and problem-solving skills. So first, a point. So a point is an exact location or position in space and has no dimension. So meaning it has no length, width, or height. So it is commonly represented by small dot and labeled using a capital letter such as point A. So points are considered the most basic elements in geometry because they help identify positions, mark endpoints of segments, define shapes, and serve as references when describing geometric figures and relationships. So next is line. So a line is a straight path made up of infinitely many points that extend endlessly in both directions. So it has only one dimension, which is length, and it does not have width or thickness. So lines are usually named using any 2 points located on them, such as line AB. So in geometry, lines help show direction, connect points, form shapes, represent relationship between figures, and serve as the basis of angles, segments, and rays. A plane is a flat, two-dimensional surface that extends infinitely in all directions. It has length and width but no thickness. Planes are often represented by slanted parallelograms in diagrams, although they actually continue without end. So a plane contains many points, lines, and shapes and is used to represent flat surfaces in geometry. So planes help describe the position of figure, show relationship between lines, and provide a space where geometric shapes are drawn. So next is triangle. So a triangle is a polygon with three sides and three angles. So the sum of its interior angle is always 180 degrees. So important triangle concepts include altitude, median, angle bisector, area, and congruent triangles. So understanding triangles help us solve many geometry problems. There are elements of triangle. First is altitude of a triangle. So an altitude is a perpendicular line drawn from a vertex to the opposite side of its extension. It measures the shortest distance from the vertex to that side. Next is median of a triangle. So a median connects a vertex of a triangle to the midpoint of the opposite side. So it divides the triangle into two smaller triangles or equal area. And third is angle bisector of a triangle. So an angle bisector splits an angle of a triangle into two equal angles. It also divides the opposite sides into segments proportional to the other two sides. And fourth is areas of a triangle. So the area measures the space inside a triangle, so it can be found using formulas like 1/2 times base times height or Heron's formula with side lengths. So congruent triangles. So congruent triangles have identical shape and size. All corresponding sides and angles are equal. So they can be proven using criteria like SSS, SAS, or ASA. Next is right triangle. So a right triangle has one angle exactly 90 degree. So the side opposite this angle is called hypotenuse, which is the longest side. So it follows the Pythagorean theorem. So right triangle contain one 90-degree angle. So importance includes the geometric mean is a value that lies between two numbers or segments. In triangles, it helps create proportional segments, meaning the ratio of one segment to the geometric mean equals the ratio of the geometric mean to the other segment. So it is used in similar triangles. So in a right triangle, the altitude to the hypotenuse is a perpendicular line drawn from the right angle vertex to the hypotenuse. So it divides the triangle into two smaller right triangles, so each similar to the original, and helps calculate lengths using geometric mean relationship. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. It is used to find missing side lengths in right triangle. So the converse of the Pythagorean theorem determines if a triangle is right triangle. So if the square of the longest side equal the sum of the squares of the other two sides, the triangle is right angled. So next is polygon. So a polygon is a closed two-dimensional shape made up of straight line segments called sides. So there are types of polygon. So first is triangle. So a polygon with three sides and three angles. So it is the simplest polygon and can be different types. Next is quadrilateral. So a polygon with four sides and four angles. Example includes square, rectangles, and trapezoid. So third is pentagon. So a five-sided polygon with five angles can be regular with equal sides and angles or irregular. Fourth is hexagon. A six-sided polygon with six angles. Regular hexagons have equal sides and angles often seen in honeycombs. Heptagon. So a seven-sided polygon with seven angles, so it can be regular with equal sides or irregular. And next is octagon. So an eight-sided polygon with eight angles, so stop signs are commonly shaped as regular octagons. And seven is nonagon. So a nine-sided polygon with nine angles, so can be regular or irregular depending on sides, lengths, and angles. So next is decagon. So a 10-sided polygon with 10 angles. Regular decagons have all sides and angles are equal. So next is quadrilaterals. Quadrilaterals are four-sided polygons. Some of them have special properties, so we call them special quadrilateral. So first is trapezoid. So a trapezoid is a four-sided polygon with only one pair of parallel sides. So the non-parallel sides are called legs, and it can have right, isosceles, or scalene forms. And next is parallelogram. So a parallelogram is a four-sided polygon with both pairs of opposite sides are parallel. So opposite sides are equal, opposite angles are equal, and diagonals bisect each other. There are properties of special parallelogram. First is rectangle. So a rectangle is a four-sided polygon with opposite sides equal and all angles is 90 degrees. So its diagonal are equal and bisect each other, making it a special type of parallelogram. Next is rhombus. So a rhombus is a four-sided polygon with all sides equal and opposite sides parallel. So opposites angle are equal and its diagonal bisect each other and right triangle. So lastly is square. So a square is a four-sided polygon with all sides equal and all angles is 90 degrees. So its opposite sides are parallel and diagonal are equal, so bisecting each other at right triangle. So part of circle. So first is center. So it is the fixed point inside the circle from which all points on the circle are equally distant. And next is radius. So a line segment from the center to any point on the circle. So lastly is diameter. So a line passing through the center connecting two points on the circle. So it's twice the radius. Now, let's proceed to geometric solid. So geometric solids are three-dimensional shapes with length, width, and height like cubes, spheres, and cylinders. So they have faces, edges, and vertices forming real-world objects. So understanding solid help in measuring volume, surface area, and solving real-life problems in construction, packaging, and design. So there are the real-life example of geometric solids, which includes cubes, cylinder, rectangular prism, coin, and others. So prism and cylinder. So definition and key concept. So a prism is a solid with two parallel congruent bases connected by rectangular or parallelogram faces. So its shape depends on the base, like triangular or rectangular prism. So it has volume and surface areas formula. While a cylinder is a solid with two parallel, congruent circular bases connected by a curved surface. So it has no vertices or edges. So its volume is base area times height, and surface area includes bases plus curved surface. So these are the real example of prism and cylinder. So in conclusion, in this lesson, we explore the fundamental concept of geometry, beginning with points, lines, planes, and angles, which form the basis of all shapes. We studied triangle, including right triangles, their properties, and K-theorems. We also learned about polygon, special quadrilaterals like rectangles, squares, and rhombuses, and circles, focusing on their parts and relationship. Finally, we examine three-dimensional geometric solid such as prism, cylinder, and pyramid, learning their characteristic and measurements. Understanding these concepts enhances logical thinking, strengthens problem-solving skills, and help apply mathematical knowledge to real-life situations effectively. That's all for today. Thank you everyone for watching and learning with me today. I hope you found the lesson on plane geometry helpful and interesting. So every lesson you review brings you one step closer to passing the lead.